Good day. So in this video, we are going to discuss the hyperbola function. But before we get into it, I just want to take this moment to appreciate those who have subscribed to this channel. And if you are new and haven't subscribed, please subscribe and share the videos as they may help some students in dire need. So what drives me is the passion that I have for students, and I don't believe there is a dumb or an average student. I believe if a student is given an opportunity and equipped with understanding, they can excel in any mathematical or scientific concept. So this video is mainly targeting the students who are doing functions in grade 10, grade 11, and grade 12. So yeah, without wasting much of your time, let's get into it. But first of all, we just need to understand what is a hyperbola function. So the hyperbola function is a function with a general equation. You need to know this general equation. F of x is equal to a over x minus p plus q. And I'm going to explain what a symbolizes, what p is, and what q is in a moment. So when you usually sketch such a graph, you end up with a graph like this one, or this one with two parts of the graph. There is another part in the other, like in the opposite quadrants. So yeah, in the next section, I'm going to explain the key features. So like the A's, the P, and the Q. What do they do to the graph? Now, moving on to the key features of the hyperbola. What are the key features of the hyperbola? So remember, we say that we have got a general equation, y is equal to a over x minus p plus aq. But what is p and q? So p is the vertical asymptote. It's called an asymptote. Asymptote. So maybe you haven't met such a term. In asymptote, it's very easy to define. So let's suppose you have got an equation y is equal to 1 over x. So let's say x is equal to 2. You end up with y is equal to a half. So let's say x is 4. You end up with y is equal to a quarter. Actually, a half is 0.5, and a quarter is like 0.25. And let's say x is a tenth, you end up with 0.1. And if x is becoming bigger and bigger, so if it's 100, you end up with 0.01. So as the x tends to get big, you are approaching 0. As you can see, so if x is 1,000, so you've got 1 over 1,000, and that is going to be 0.001. You are approaching 0, but you are not touching 0. So the graph tends to like touch the 0 line. So the graph will come on like that, trying to touch the 0 line, but it will never touch it until infinite. Even if it's x 1 million, it's like 1 over a million. That is 0.0000001. And you don't touch the 0 line. So that is what is called an asymptote. So yeah, the graph of hyperbola has got two asymptotes. So it is the P and the Q. So the P and the Q are the asymptote. And the P is called the vertical asymptote. Okay, so that is the vertical asymptote. So if you have got a Cartesian plane, so this asymptote goes like that. So you always symbolize it like with a dashed line. So that is the asymptote. So if it's at 2, so that is the asymptote at x is equal to 2. Okay. Then the Q part is called the horizontal asymptote. That is the horizontal asymptote. So the horizontal asymptote cuts through the y-axis. So it goes like that. So if y is equal to a 4, that is, so the horizontal asymptote in this case will be y is equal to 4. So those are the two asymptotes of the hyperbola. P and Q are the asymptotes. So one thing that you need to remember is that if you have got your x minus p, if it is x minus 4, the vertical asymptote is actually equal to positive 4. So for example, if you have got equation y is equal to 3 over x minus 2 plus 3. So what it means, x minus 2 here, it actually means if you want to find the value of x, that is x minus 2 is equal to 0. So x is equal to 2. So it's actually a positive. But for y, it doesn't matter. It's always a positive or a negative as it is illustrated. So if you're asked what is the vertical asymptote of this function, that will just be equal to x is equal to 2 and y is equal to 3. And that is 1 mark in an exam and another 1 mark there. 2 marks, easy marks, just to point out those asymptotes. Remember the equations, x is equal to and y is equal to. Okay, so that is the P and Q. These are horizontal and vertical asymptotes. Then the other feature of this graph is the A. So if your A is greater than 0, so A is positive. So if A is positive, we tend to have the graph like this. So let's say this is now your horizontal asymptote and this is the vertical asymptote. So the graph that results will be a graph in this format. So it will be in this quadrant, in that quadrant. So the moment you've got A as positive, that's know that the pieces of the graph will be in those two quadrants. Then if A is less than 0, so A is negative, that's what it means. A is negative. So if A is negative, you tend to have now, if you've got that vertical and the horizontal asymptote, then the graph will be in those two quadrants, so the opposite quadrants. That's what A does to this kind of a function. So it's either the first quadrant and the third, or the second quadrant and the fourth. That is the other feature of A. So P and Q are asymptote, and A determines the shape of the graph and the position in terms of the asymptotes, either in the first or third quadrant, or the second or the fourth quadrant. So now let's look at some examples and discuss these features further. Now, in this example, y is equal to 3 divided by x minus 2 plus 3. So the first feature that we want to talk about, remember, is your vertical asymptote. So that's your vertical asymptote. And in this case, your vertical asymptote is x is equal to 2. That is the equation of the vertical asymptote. And the horizontal asymptote, will be equal to y is equal to 3. So we just read out these values. X is equal to 2 and y is equal to 3. Those are your vertical and the horizontal asymptote. Then the other feature that you want to talk about is the x-intercept. So for the x-intercept, remember, for the x-intercept, you let y is equal to 0 to get the x-intercept. So we let y is 0. So if y is 0, we have got 3 divided by x minus 2 plus a 3, which can be further simplified to a negative 3 is equal to 3 divided by x minus 2, which can further be simplified negative 3x plus a 6 is equal to a 3, then which can be further simplified to 3x is equal to a negative 3, then x is equal to a 1. So it's positive 1. That is the x-intercept. Then the other feature that we want to talk about is the y-intercept. So the y-intercept, you let x is 0. So x is 0. So there are marks for calculating these things. Actually, there's a question which can ask you, calculate the x-intercept, 1 mark. Calculate the y-intercept, 2 marks. So those are very easy marks to get. So the y-intercept, you let x is 0. So in the same equation, y is equal to 3 divided by 0 minus 2 plus a 3. Then when you simplify that further, you realize that y is actually equal to, that would be 3 minus 3 over 2. That would be a 3 over 2. So you have got now your y-intercept, x-intercept, you've got the horizontal asymptote, and the vertical asymptote. With that in mind, you can be able to sketch this graph and to get all the 10 or 11 marks for free. Now, let's move on to sketch that graph of y is equal to 3 over x minus 2 plus 3. And remember, we say that our vertical asymptote was x is equal to 2, and horizontal asymptote y is equal to 3, and x-intercept x is equal to 1, and y-intercept is y is equal to 3 over 2. So when sketching this graph, the first thing that you want to do is to indicate your asymptotes. So they should be clearly indicated. So remember, it's x is equal to 2. So this is a vertical line passing through x is equal to 2. That 2 needs to be clearly stated. And also remember now, the horizontal asymptote was at y is equal to 3. So that is the first thing. You need to put down your asymptotes, vertical and horizontal asymptotes. Then the next thing that you need to do is to get your intercept. X-intercept is 1, so 1. That needs to be clearly stated. And also the y-intercept is 3 over 2, so it's in between here. So 3 over 2. And remember, we said if 3 is positive, you can actually see these 2 points. You just draw them. You just draw the curve like that. So that is the other part of the graph. And obviously, the other part will always be in the opposite part of the asymptotes. So you see again, your A is positive 3, then you expect your graph to be in the first and third quadrant. They're not really quadrants, but on these other opposite sides of the asymptote. And this is the point of intersection of the two asymptotes, and that is the point 2 and 3. And that is how you sketch this graph. And these are easy 4 marks to get. So yeah, that is how you do that graph. Now, the other thing that we need to discuss is the domain. The domain and the range of this graph. Remember, the domain is always read from the x-axis. You always get your domain from the x-axis. And for the hyperbola, the domain of this graph is x is an element of all real numbers, all of them, except that x cannot be equal to that vertical asymptote, which is 2. Then that's how you do the domain of the hyperbola. Then for the range, you look on the y value. So this is the y-axis. So for the range, you just say again, y is an element of all real numbers, but y cannot be equal to the horizontal asymptote, which is 3. It can't be 3 because if you take, for instance, if you take x as 2, if you put 2 there, 2 minus 2 is 0, then 3 divided by 0, it's undefined. You can't divide any number by 0. It's always undefined. So that's how you do these things, the domain and the range. So in the next section, we want to look at the axis of symmetry. That is the last part of the hyperbola. So yeah, one of the things that you can be asked to determine is the equation of the axis of symmetry, or just the axis of symmetry. But what is a symmetrical line? Remember, if you have got a shape like a triangle like this line can be a line of symmetry. So you just fold the shape to be exactly a replica or an image of each other, or two equal parts. So in what way can we fold this graph to be a symmetrical graph? And you can see we can fold this graph in this line passing through it has to pass through this point of intersection of the horizontal and vertical asymptote. So if you fold this graph like this, you can see that you can have a symmetry. Or alternatively, this can be folded in this line as well. And you can see when you fold it in that line, you can have also an axis of symmetry. So these are the axis of symmetry. So what you are basically asked is to determine the equations of these lines. So to determine the equations of those lines, one thing that you need to know is that it is always stated that the gradient of this other line going in that direction, its m is always equal to 1. The gradient of that line is always 1, positive 1. And the other gradient of this line is m is equal to negative 1. So the gradient of the two axes of symmetry of a hyperbola, it's always 1 and negative 1, and they pass through a common point, the point of intersection of the two asymptotes. So now to determine the equations of these lines, you can see that these are straight lines. So a straight line has got a general equation, y is equal to mx plus a c, where your m is the gradient. So in this case, we want to start off with this one. So m is 1, so y is equal to 1x. There's no need to write the 1, so it's just x plus c. Now, to get the value of c, we substitute any other given point on that line. And you can see the given point is the point of intersection of the two asymptotes, the vertical and the horizontal. So we substitute that. So y is 3 is equal to 2 plus c, then c is equal to a 1. So this equation can be written as y is equal to x plus 1. That is one equation of the axis of symmetry. So that is that equation there. Then for the other one, remember, the gradient, it's negative 1. So y is equal to negative 1 plus a c. Again, the common point is 2, 3. Then we substitute that point. 3 is equal to, actually an x there should be negative x. So 3 is equal to negative, then the value of x is 2, so negative 2 plus c, and your c is equal to 5. And therefore the equation of this will be equal to y is equal to negative x plus a 5. Then you've got the two equations of the axis of symmetry. So yeah, to summarize this lesson, remember we said the general equation of the hyperbola function is y is equal to x minus p plus q, and your p is the vertical asymptote and your q is the horizontal asymptote. And remember we said again the domain of the graph of the hyperbola is always x is an element of all real numbers, but x cannot be equal to the vertical asymptote. X cannot be equal to p. And also remember we stated that the range of the hyperbola function y is an element of all real numbers, but y cannot be equal to q. And yeah, that's most of the things that you need to know in the hyperbola. And also remember, when you've got your vertical asymptote and horizontal asymptote, and if a is negative, you should expect your graph to be on those two sides of the asymptote. And again, if a is positive, you should expect again the graph to be on that part of the asymptote. So that is a is greater than 0. So yeah, that marks the end of this lesson. Please let me know what you think. I hope you understand everything. And please remember, if you haven't subscribed, subscribe to the channel, and hope to see you again in the next lesson. Bye.